Let's see about how to store and access array elements. Now, whenever we declare an array int a of 5 elements, so continuous 10 bytes will be allocated for storing 5 integer values. So continuous 10 bytes, each element will occupy 2 bytes. And for all these locations, there is a single identifier is assigned, that is an A. Now, if there is a single name assigned, how do we access each location? Each location has been identified by an index number starting from 0. So the first location is identified with an index number 0. The second will be 1, 2, 3, 4. That is, if you have created an array of 5 elements, then the index number will range from 0 to 4. If it has been 100 elements, A of 100, then index number will range from 0 to 99. So now, if you want to store 10 in the first location, then you can do it by giving your array name. Within square bracket, the index number has to be given. Okay, the index number is nothing but 0 is equals to 10, then the 10 will be stored in this first place. So if I want to store 20 in the second location, then again array name within square bracket, its index number is going to be 1 is equals to 20, then the 20 will be stored in the second place. Same way, in the fourth location, if you want to store 50, then fifth location, if you want to store 50, then its fifth location index number is 4 is equals to A of 4 is equals to 50, then 50 will be stored here. So this is how we store the data. Now, instead of storing, if I want to read the data using an scanf, then you can generate this index number using a loop where you can give a int I equals to 0. That is, I want up to 4 index number. So I is less than or equal to 4 or else less than 5 can be given I plus plus. And you can read it by giving a scanf %d, that is ampersand of A of I. So first time I value will be 0, so it will take here this as an A of 0. That means if I give 10, the 10 will be stored in that first location. Same way next again goes back, I value is going to be 1 and it is going to take this as an ampersand of A of 1. If I give 20, then 20 will be stored in the second position. Same way, when I value is 2, then it will read here A of 2 location value. When I value is 3, it will read here A of 3 location value. When I value is 4, it's going to read here A of 4 location value. Let's take here the data is being given like this. So this is how we store the data or read the data and then store into that array. Same way, if you want to access the data and store into some variable, like for example, x is equals to, x should have here A of 2 location value. A of 2 location is nothing but 30. Then you can give here x is equals to A of 2. That is, A of 2 value is nothing but 30. The 30 will be stored inside this x. Or else if you want to display all the array elements, then you can take again a loop for generating natural number, that is index numbers, starting from 0, I is less than or equal to 4. So less than or equal to 4, and then give her I plus plus and printf /n %d, then you can give her A of I. So this is how we can store and access the data from an array.